Question 7 says a particle of charge q and mass m is moving with a velocity minus v I cap where v is not equal to 0 towards a large screen placed in the yz plane at a distance d. If there is a magnetic field B equal to B naught k cap, the minimum value of V for which the particle will not hit the screen is. Let's analyze the situation with the help of a diagram. So, the screen in fact is placed in the yz plane according to the question. So, let's say that the axes look like this. This is the x axis, this is the y axis, and the z axis is pointing outward. Okay. Let's say that the particle at an instant is here, it has velocity v towards left because it is minus v I cap. So, v is the velocity, its mass is m and charge on it is q according to the question. The screen is placed in the yz plane, that means screen is placed like this, and the direction of the magnetic field is along the z axis, that means it is pointing towards the positive z direction, B naught k cap. So, what is the direction of the magnetic force on the particle? The magnetic force is given by q into v cross b. So, v in this direction and B naught in this direction. So, the magnetic force is in the upward direction, considering that charge q is positive. So, that means its center of curvature will be perpendicular to this line somewhere here. Let us say the center of curvature is here. So, that means its path has to be a circular path with the center of curvature at point C, and let us draw the path. It goes something like this, it will go further and it has to go something like this. Now, according to the statement of the question, the particle should avoid hitting the screen. So, that means the radius of its path should be less than the value d. This separation in fact has been given as d, and this is the radius. So, for the collision not to happen, the condition is that the radius of its path r is less than d, which means the radius itself is given by mv divided by qb naught. So, we have mv by qb naught being less than d, which means the speed v must be less than q b naught d divided by m. So, that means the maximum value of speed can be q b naught d by m. Okay. Now, if we look at the question says the minimum value of v. So, which clearly is an error. We found that the maximum value of v comes out as q b naught d divided by m. So, let us go for that option, option 4, and read it as the maximum value of v for which the particle will not hit the screen, because the minimum value of v does not make any sense here. Let us now go to question number 8. Question 8 says 4 point masses, each of mass m, are fixed at the corners of a square of side L. The square is rotating with angular frequency omega about an axis passing through one of the corners of the square and parallel to its diagonal as shown in the figure. The angular momentum of the square about this axis is. So, we have to find the angular momentum of this rigid body, which is consisting of 4 particles, and the angular momentum in such cases is given as I into omega, where I is the moment of inertia of the system about the axis of rotation. Omega is already given to us. We have to find the value of I about the axis of rotation. Now, there are 4 particles in this system. This particle is on the axis itself, so it will not contribute anything to the moment of inertia. Let us now evaluate contribution to moment of inertia due to the other 3 particles. Now, if you look at these 2 particles, their perpendicular distance from the axis in fact is equal to half the diagonal of the square. Okay. So, that means this distance, if we show this distance with the help of a dotted line, let us draw a perpendicular from the particle to the axis, and let us stretch this line further. So, this is the distance of this particle as well as this particle. And what is this distance? As I said, this is half the diagonal, that means it is equal to L divided by root 2. So, the expression for moment of inertia then becomes, I is equal to, for the first particle it is 0, for these two particles it is 2 times m into L by root 2 whole square, and finally for the fourth particle it is m into L root 2, and then we have to square it. So, this is the total moment of inertia. This comes out as 3m into L square, and that means the angular momentum of this system about the axis of rotation will be 3ml square into omega, which means option 1 is correct. Let us now go to the next question. Question 9 says a clock has a continuously moving seconds hand of 0.1 meter length. The average acceleration of the tip of the hand in units of meter per second square is of the order of. Well, the acceleration of the tip of the hand is basically the centripetal acceleration directed towards the center of the circular path, and the expression for the centripetal acceleration is A is equal to omega square into r. Okay. R is given, the length in fact has been given 0.1 meter. Let us evaluate the value of omega, and it is a seconds hand. So, a second hand completes one revolution in 60 seconds. That means the value of omega, angular speed of the tip, is equal to 2 pi radian divided by 60 second, or pi by 30 radian per second. So, that is the angular speed. Omega square r then comes out as it is equal to, so we are now calculating the value of the acceleration, the centripetal acceleration, which is omega square r. So, this is coming out as pi square into 0.1 divided by 30 into 30, and the units here are meter per second square. So, that is the value of the centripetal acceleration, and if we look at it in terms of the order of the magnitude of acceleration, this comes out after calculating very close to 10 to the power minus 3. So, the order that is being asked of the acceleration of the particle at any instant is coming out as 10 to the power minus 3 meter per second square. Let us now go to question number 10.